And I'm happy to introduce this next section, this next segment, which is going to be really fun. It's featuring Thomas Searles, who is an associate professor of electrical engineering and computer engineering here at University of Illinois, Chicago. He also, for example, it does many very interesting things in research, including machine learning for quantum computing, integrated quantum photonics. He's also leading a large DOE project to develop quantum engineering curriculum. And he is joined by Walter Massey, who has a very long list of accomplishments. If I were to read all of them, that would be a lot of our half hour, but has influenced many of us. So he was previously a director of Argonne National Laboratory, previously director of the NSF, also president of the American Association for Advancement of Science. He was also a professor of physics, both here at UChicago, also at Morehouse College, also at UIUC, so a lot of influences there. And then also amazingly, was also at one point the president of the School of the Art Institute for Chicago and also chairman of the Bank of America. So I don't know of anyone who has this kind of a broad portfolio. I am super looking forward to hearing the interaction between these two. It's going to be sort of an unrehearsed two-man play or something like that. So I will turn this over to Walter.
Okay. We were asked, I like your shoes, by the way.
Thank you. They're special edition Morehouse College.
Wonderful. We were asked to speak about growing the field. And I think one aspect of that is growing it, diversifying it, growing it broadly, but also getting more participants from people from backgrounds who may not have traditionally been in the field. So I thought we started by just talking about similarities in our background, even though we're far removed in age. We both attended Morehouse College in Atlanta, Georgia, of which I was president, but I had left before you were a student.
Oh, you were still there? Yes,
I was still one of my students. Right?
Yep. I'm a man of Massey. That's what we call ourselves.
Right. And we both went on to, I went on to Washington University, got my PhD in physics, and you went to Rice, so we both went to almost southern schools, and here we wind up at Chicago. I thought, Thomas, I just might start by saying a little about my experience in diversification of science and physics in particular. When I got my PhD in 1966, there were about 20 black PhD physicists. We all knew each other. In 1978, I was one of the co-founders of the Society of Black Physicists, which is now the National Society. You're very useful. And there were maybe 80, 60 or 70 of us. Now there are several hundred.
Yes, sir.
Members of the National Society. Also, there's the National Society of Black Engineers, which is very active, and the National Society of Black Chemists and Black Chemical Engineers. So what have you seen during your tenure and your period coming up in the sciences in terms of diversifying the field?
Oh yeah, most definitely. I mean, thank you so much for also not only serving as president of Morehouse while I was there, but being an example for a lot of the Morehouse students and now Morehouse kind of men as scientists that can really have a career in physics. Not everyone is able to have that kind of mirror or to see what it would look like. And I'm very fortunate to have Dr. Massey as somebody to look up to.
Walter.
Walter.
I'll
try.
Walter.
I'm from the South, so I'll try to work on that, Walter. So I grew up in Albany, Georgia. We were ahead in the times of some things and then behind in others. Something that we were ahead when I was in high school was taking physics out of the curriculum. I was the only physics student, AP physics student, actually, that was able to take physics during that term in Dougherty County. And that was all as a testament to what I call my Panther mom, that was able to go to school board meetings and fight for the fact that she knew that I wanted to be an astronaut one day, and she knew how important it was for me to study physics. It just so happened that I ended up going to a place like Morehouse College and having classmates that are now truly leaders of the field in quantum, people like J.D. Whitfield, that works at Amazon, and also Dartmouth College, my colleague that's doing a lot of things at UIC with me, Zizway Chase, those were my classmates. And I didn't know how lucky I was to be in a place like Morehouse. Now, as you said, NSBP has grown. Our conference will be in November. We have around 600 people that will be there. We've just reached over 100 Black women that have PhDs in physics, so we're very proud about that. However, as we'll discuss a little bit later, there are still some things that can be improved.
Well, I find this field of quantum to be very interesting. It seems to be, can't remember in my career anything that seems to be has developed so rapidly from a theoretical concept to practical application. I think the young woman, Aziza, from MIT, who showed 1930s entanglement as a paradox and a point of discussion, and then a few years later, a discovery without clearly understanding it, and now already applications. And the CEO of Psi, those of you who were here yesterday, said, quantum computing has an insane gravitational pull on people and funding. What is it about? Is this an opportunity using this field to really attract more people in it from minority populations who haven't gone into physics naturally and normally because there's so much excitement here? Do you see anything unusual about this opportunity now with this field?
Oh yeah, most definitely. When I graduated from Rice University in 2011, your options were to go to Los Alamos and do a postdoc, or to go work in the oil companies. So those were kind of it. And then, of course, the traditional route of going into academia, right? Now you have it such that students are being poached right off of the bench in AMO labs and getting very high-paying jobs. One of the companies here, AeroQ, which we'll talk a little bit about later, they've done a great job of expanding and hiring young PhDs as quantum engineers. And one of them actually said to me that that experience really reinvigorated her excitement for science. Being able to work on something new and be at the ground stage and to develop that. And it's really and truthfully why I'm so excited to be in a place like Chicago and to be able to encourage young people and use this Illinois Quantum and Microelectronics Park as a beacon for young people to say, hey, I can go to U Chicago, I can have a job, I can have a pathway to really make a change in my life and my community. And then even people that are brothers that went to Morehouse that were from Chicago, a lot of them want to return and have a place to go back home and see their mother and grandmother grow in age. And I really feel like it's an opportunity for, it's something like $60 billion of economic impact from the Block Tech Hub. There's going to be something like 50,000 students trained. And there's a large number, which I'm very concerned about us reaching, which is this concept of having 30,000 jobs filled. Where are the students going to come from? And that's something that we're actively working on. One of the things that we do with the IBM HBCU Quantum Center, which I founded in 2020, was that we really encourage, we have a Women in Quantum series that just started. It's on YouTube. And we really focus on women of color that are in the quantum space, that are working in different industries. And we have it housed at our sister school, Spelman College. So we invite these speakers to Spelman on purpose, such that the Spelman students are able to interact with current quantum scientists and really learn about what it means to be a woman in this field, which is very different than my experience. I know that because I have 4 women of color that are my PhD students, and they remind me almost every day how different it is for them. So I think doing these targeted investments and really starting early. I always tell people, of course, you have the quantum hype and you have these roadmaps. I'm 41 years old, Dr. Massey. I may or may not ever see a quantum computer. However, when you all are at the game night tonight, you might actually meet a student that might be a 4th grader or a 5th grader that will actually see this into fruition. So it's important to be excited about it. It's important to be real about it. but it's also an opportunity, I think, in the city of Chicago for sure.
Well, time, I'm familiar with the time it takes to do important things. I'm chairing a project called the Giant Magellan Telescope, the world's largest ground-based telescopes in Chile. And we started in 2002, and first light we think will be 2030. So I won't see it. Somebody will see first light. But I was involved with a project called P33. Some of you may know about it here in Chicago. And it was an effort, it's now up and going, but it was an effort to create what's called an information technology ecosystem in Chicago, and to have it as, to bring universities, national labs together, venture capitalists, all the things the governor talked about yesterday, if you were here, what it takes to create these kind of creative ecosystems. And quantum is part of this OP33 effort. When we were planning this and developing it, one of the core themes we focused on was that we wanted to create an ecosystem that reached everyone in the Chicago area. We didn't want to recreate a Northern California, and maybe if I'm disparaging it, fine, but a system where the overwhelming wealth that came out of the technologies that accrued to a few people. And so equity across the system is something that we really wanted to promote in P33. So how do we sort of make sure this happens as quantum grows with these hundreds of millions of dollars, billions being invested? I was chairman of the Community College District of Chicago for quite a while, and I see that as one avenue to reach youngsters who may not be doing research of the type that wins a Boeing Prize, but also would be able to participate in these very exciting activities. Could you say a few words about your thoughts on that? Because I know you've been engaged in these kinds of activities.
Oh yeah, most definitely. I mean, credit to CQE and the Block Tech Hub for making it a concerted effort to work with the city colleges of Chicago and Harper College, and trying to work with my colleagues, Gina Lorenz and also Paul Kwiat and myself on this concept of putting public quantum networks at each of the community colleges in the state and in the city. That's one of the ways that we want to do that. I actually had an experience when I was faculty at Morehouse College where I taught at Atlanta Metropolitan State College, which was a 2-year institution. And what I found was that those were no diss to my students at Howard or the great students at UIC, but those were, to me, the most engaged and involved physics students that I had in my career. Some of them are actually, I met one at NSBP and she asked, hey, aren't you a professor? And of course I said no. But when I started to talk to her, what she was telling me was that she just was a PhD candidate and she was defending her PhD in astrophysics at Ohio State. And she came from that 2-year institution. So I think there's a lot of talent in this country, and the numbers show it, right? That right now, if we're trying to create a quantum physicist, 41% of that load is on the traditional physics department. Only 19% of that load is on engineers. One of the things that we want to do at UIC, and is happening at UIUC and other places around the world really, is the development of these quantum engineering programs to try to push for scalability and try to involve more and more students. Shout out to UIUC though, because they graduated 160 of the it's around 370 students that got a BS from the state of Illinois in physics. And the UIUC department actually graduated 160 of those, right?
Oh.
Now, outside of that, then the numbers get very, very, very small. If you look at the entire HBCU space last year, there were only 80 students that graduated with a BS in physics. So UIUC themselves are double that from around the entire nation, right? So it just has to be more than our traditional route. We have to think outside the box. One example that I'll pull is that through the IBM HBCU Quantum Center, working with duality, and in particularly QuantCAD. I don't know if Jennifer's in the building today, but we had a Morehouse student that was a business major. And he was able to work at CQE within the context of learning business development for a quantum startup in the city of Chicago. And that's one of the proudest moments that I had this summer, was when he said to me, hey, you know, Doc, I actually really like experiments too. They're allowing me to do experiments while I'm learning all these other things. And I really think that, yes, the traditional route works. That's how I got here, that's how you got here, that's how a lot of my friends that I went to school are able to be quantum physicists and have a great career. However, this is an opportunity to bring more people to the table and to actually give them the opportunities to learn about what's going on, regardless of if the quantum computer happens tomorrow or if it happens 20 years from now. I got my PhD in carbon nanotubes. One of the things that they said was that they were going to build a space elevator. I'm still waiting on the space elevator. So I think it's more of showing students that there's actual things that they can do that are exciting, keeping that fire inside of them. I'm sure you had that same fire at some point very early on, that till this day you're still very involved in science. That's something that I aspire to do, is to still always have that bug inside of me. My students won't let me get in the lab as much as I like to because they're scared that I'm going to break something. However, you just do science in a different way. One thing, speaking on that note, Dr. Massey, one of the qubits that didn't really get a big highlight today is this platform of electrons floating on liquid helium. And I actually point that out because the company AeroQ made an investment into the west side of Chicago in Humboldt Park, where they have 5 to 6 deal fridges and have students from UIC. So Dr. Chase takes his class there, I take my class there. A lot of students are able to see that right there. Now, I'm not gonna give the date of your PRA and PRB paper, I'm sorry, your PRL papers around this concept of quantum fluids. But what interested you in quantum fluids to begin with? And then also, could you ever imagine that work on liquid helium back then could now be something like a qubit?
You heard of qubits. No, I'm a theoretician. I really worked on many body systems, period. And one example of that was liquid helium, superfluid helium, and that got me in the quantum many body systems. But it's just mind-boggling how much this has changed during my career. And the methods of calculation, I used to punch Fortran cards, also to the theoretical concepts. No, I never thought about really practical uses of helium, especially in the way we're using them now in quantum systems. One of the things, 2 things I want to make sure about. One is that one of the ways we get, as we all know, get people into science is getting them interested in these things very young. And I'm sorry I'm going to miss this high school program tonight where they're showing these games to high school kids. I've gotten peripherally involved with the program here in Chicago called STAGE, Scientists, Technologists, Artists, and Engineers for Education, STAGE. And they are sponsoring some of these games, and they make a lot of these games that illustrate the quantum theories and quantum dilemmas for youngsters. And they make games out of them. I think that's marvelous. But I'm gonna switch slightly. So, to my 3 things. First of all, fusion, when I got my PhD, fusion was 40 years in the future. Fusion is still 40 years in the future, right? Practical applications. So don't worry about time in developing these things. Before we have to wind up, so what does all this mean for the nature of reality? You know, as I look back these arguments about, does quantum mechanics really describe the natural world, or is it just convenient and happens to be portion in mathematical formulations that can help us solve problems? You know, the Freeman Dyson was someone that just shut up and compute. You know, don't worry and argue about what it really means. And, you know, the old Copenhagen school, Niels Bohr, that school, we got to have complementarity because the quantum world may not really be observable to us. Now, we're living in the quantum world. Sending entanglements down a tube. I love that. Teleportation, action at a distance. You need a philosopher as part of this quantum exchange, so we can talk. How do we think now? How is this causing us to think differently now that we see that the quantum world is a macro world?
Yeah, I mean, correct me if I'm wrong, IQUIS, but I think there might be some philosophy folks that are in part of the IQUIS Center.
We have a philosopher.
Yeah, so there is a philosopher that's a part of IQUIS. So I think that people are thinking of that way. But back into your point about quantum games, and I think the importance of it is this idea of building, quote unquote, quantum intuition, right? One of the easiest things to do, and people pick at me when I teach the introductory physics classes, is that I'm moving around and I'm throwing things and I'm describing being in a car, because if you're looking at physics, which is the study of the natural world, this is the world that we live in, and that world is quote unquote classical. So it's very easy to explain to somebody why they might fall or why they might not fall. But now you have this idea of why things happen that may or may not happen. And I think actually my colleague Paul Kwiat, who has a fantastic taste in bow ties and is a leader in this space of quantum optics and AMO, and particularly quantum state tomography, which is near and dear to my heart. One of the things that he's doing is he has an escape room.
He told me about this.
Called Lab Escape. And I think the combination of having the Illinois Quantum and Microelectronics Park and having a space where the students that grow up on 79th and the 80s and even the 100s, one of the best quantum physics students at UIC is from the 100s, a guy by the name of Caleb Williams. He got his first passport by going to the Waterloo School, summer school for quantum science, right? That experience has now changed the way that he views the world. So can we replicate that with the Illinois Quantum Park, having something like Lab Escape there, having something where there are black and brown and all shades and all colors and all likes that are actually doing experiments and working at the proving ground. I think that will not only transform the field, but hopefully it'll actually make a profound impact on America.
I think we ought to take questions if you have any.
I just wonder, what sort of jobs do you envision for the park when it first starts going? Like, can you, and I'm not a scientist, I'm a journalist, so I'm wondering, what opportunities will there be for young people?
Well, I think another person that I'll point out that I'm super proud of is Dr. Katrina Miller. She wrote an article, she actually got her PhD in astrophysics from UChicago, but in the New York Times, she actually highlights Dr. Walter Massey, and she was kind enough to give me a quote in that article. But as a physicist and as a black woman physicist, she's able to write through the lens and tell the stories of people like Dr. Walter Massey. So I think journalism is a space where more in science communication, I think a lot of the hype is due to the fact that there aren't enough scientists that are actually writing the hype stories to actually read the paper and to understand the paper and then say, that headline might look a little crazy. Are they really doing that? Because that might just be one hero device at one particular time that will not work in my laboratory. So I think that's one space. I think the idea of having business development folks and marketing, and that is also very important. As far as other jobs, I think fabrication is a skill that goes across multiple things that are very, very important in today's world. Speaking of things like the CHIPS Act, right? So at UIC, we're investing in quantum engineering, but it's more of optics and photonics. It's more of looking at nano and microfabrication for students, and even AI and data science. How do all of these things work together? And I think if you target kind of these more traditional engineering / physics disciplines with the lens of, I love being in the lab, but I can work on any interesting problem, and I think that there should be plenty of jobs for people like that at the Illinois Quantum and Microelectronics Park. Did you have any?
Yeah, I think the beauty of that is, first of all, I want to second your comments about the journalists. Thank you for being here, being a journalist. We need more journalists who cover this. But the beauty of this park is that it's going to need people with all level of skills. First, they have to build it. So there are going to be jobs in the beginning, traditional construction trades and that kind of thing. But then there are going to be jobs for people who come out of Richard J. Daley Community College, where they have a digital manufacturing laboratory there. Well, they'll be able to go right in and have jobs in the fabrication parts of the process that will be used there. And then there will be research laboratories, presumably. That's part of the institute that would be there. The thing I also like about it is I don't think everything is already determined. One of the things that comes out of bringing creative people together, especially scientists, tech, and engineers, is you begin to come up with other things, that you might not have planned to have there. So it's not meant to be an incubator, but it's going to incubate new ideas, I think.
Thank you guys so much. So my question is, you made an especially poignant point about how few physics degrees are awarded in Illinois, and I would say that's probably true nationwide. And I was wondering if you could comment on, obviously you spoke to trying to motivate students young, and your story of being very dogged through high school and to pursue physics. How else should we be fostering education? Because I've noticed physics departments being less prominent.
You could say it. No. No, I can say something.
Sure, you start. Yeah.
And then Walter can add his comments. So I spent a lot of time on the APS Committee on Minorities. During the pandemic, I spent a lot of time with the AIP Team Up report, and then implementing those things from the report on how you can increase. It was a specific problem for Black physics students, but if you apply those methods to anyone, it'll make the physics department climate and environment and any academic climate and environment better. And these things happen to be things like personal support for students, encouraging them to, if they're having a bad time, college can be a difficult time, pointing them to the right resources, having a sense of belonging, or this idea that I was lucky enough not to have when I was at Morehouse College, because the president of my university was a Black physicist. So this concept that I wasn't a physicist was like, what are you talking about? Dr. Massey has been doing this for 50 years, right? But most students they don't have that direct connection or that belonging to what's going on. The other thing, again, is this idea that, a lot of curricula in general is under attack right now for various reasons, and especially in the sciences. One of the things that I think that we as quantum engineers and scientists should do more of is to talk to high school physics teachers, because that's really the biggest draw and the first real touch point of where quantum actually is introduced to students. And I think if we can have a concerted effort, there will be a paper that will come out soon, in this idea from a workshop about a national quantum education center that would focus on K through 12. And you know, one of the things that I do now is I put on a lot of suits and I sit in a lot of places where I never imagined that I would be, because I would much rather be in a t-shirt and swim shorts in a lab space. But I think talking to your family about kind of why this is important, encouraging people in their neighborhood about why this is important. Something as simple as going to Washington. I used to live in Washington, D.C., and this would happen, is that you would have a reception or something at Washington, D.C., and I would just walk by and then stop by my congressperson that I grew up back home and say, hey, you know, this is what physics has done for me, and I think that this is why this is important to the nation. So you really have to be what my dad used to call a citizen scientist, and really advocate for science in this country more than I don't know, Dr. Massey can give his perspective, but in my 41 years of life, I haven't had a moment where it was so important to be in the community and tell people that, hey, I'm a physicist, this is what physicists do, and this is why this is important.
Well, I think physics, I'll start from the end. You talked about the career. I think it's changing, but I've always had concerns about how we teach physics, and especially to first-year students. It's evolved quite a bit over the years, but the notion that only a few people can really understand this field, and you're not one of them if you're in this class, and if you sink or swim, that's a lot of that's gone away, but I still think some of that is around. It's the way we in the field, as Thomas said, present ourselves to others, and the way we talk about physics. I don't know how many of you are physicists or whatever, neuroscientists or engineers, or any field like that, when you're out at a social gathering and someone says, what do you do? It's I'm a physicist. Oh, I can never understand physics. That's sort of the typical thing. My wife, when she's with me, she always says, that's because you didn't have Walt to teach you. And it does make a difference in the way we teach and expose youngsters. Going back to high school. I think we've used up our time.
We did. I'm going to take my role as moderator to ask one final question, because the fact that we have someone who's actually also associated with the Art Institute, I'm curious, often if I could oversimplify humanity and divide it into the scientific-y people and the artsy type people. We've been talking a lot about jobs for the scientific-y people and technical, but I'm wondering if you could just comment on the importance or the usefulness of introducing this through art to people, and maybe to addressing the other half of society, or the other whatever fraction, by including art in some of these kinds of things.
I was president of a school, the School of the Art Institute of Chicago here, and I didn't have an art background. It's a long story how I got to be president. But one of the things I discovered is a lot of remarkable similarities between artists, designers, and scientists. This creative instinct they have, this almost obsession that this guy has, you can see, with really understanding and the world around them, one through the way you look at it and present it in art, the other way you maybe understand it through a scientific lens. But the devotion to the pursuit of knowledge comes through in both fields. And we had some very creative courses there. One of the most interesting courses that I recall was taught by a physicist. We had a physicist, an astrophysicist on faculty, and an artist. And they taught a course in general relativity to art students, many of whom had very little math at all. But they taught it through illustrations, through drawings, through concepts, through various ways. And these students, if you had a conversation with them, they could explain general relativity to you better than many undergraduate physics students whose only hadn't given a lot of thought to the concept, but who worked through the equations. So I think there's a lot of ways in which art and science can come together to help people understand both the scientific world better. And that's what this STAGE organization tries to do here.
Awesome. Well, thank you again so much, both of you. It's been a pleasure to host both of you, and let's please thank them again.
Glad we got to say Walter.